this video, we're going to talk about writing equations of midsegments. So we're going to review quickly what a midsegment is. So it's a segment that connects our different midpoints together in your triangle. So a midsegment is also parallel to the other side of the triangle, and which means that the slopes of those two segments need to be the same number and then exactly the same. Here are some different steps for how we're going to write our equation. We need to find the midpoint of both sides that our midsegment is going to connect together. Then to write our equation, we have to find the slope of that line, and then we're going to put it into point-slope form using just one of those midpoints and then that slope number. And if we want to solve for y, to put it into slope-intercept form, that we might do that. For number one, we're going to use this triangle for all of the different questions. So go ahead and graph it on the graph paper for number one. For number two, we need to find the midpoints of all three sides. So the midpoint of AB is going to be point D. So we need to add the x's together, divide by 2. This means that we will end up with 2, 2 as our midpoint. So next we need to find the midpoint of side BC. So again, we need to add the x's together, divide by 2, and add the y's and divide by 2. When we get this, we get 10 divided by 2, so we get a 5. Negative 2 divided by 2 is a negative 1. For the third midpoint, I want you to find it yourself, so go ahead, push pause, work it out, and then go ahead and check your answer. Alright, so the midpoint between AC is going to be positive 1, negative 1. And my work to go along with it is there in purple. Lastly, we're going to now draw the midsegments of our triangle, so we're going to connect the points D to F and D to E, and then E to F. So in this slide, I had to redraw my picture since I couldn't see it on the previous one like you can on your paper. So we need to find the length of AB. So to find the length of a side, we need to do our distance formula. So we need to subtract the x values of A and B, so negative 2 minus 6. Then we need to do the same thing for the y, so 2 minus 2. When we simplify this, we get a negative 8 squared, which then becomes a 64 because 0 squared is just 0 still. So we end up with 8 as the distance of AB. Some of you might have been wondering, well, why can't you just count it on the graph? And we could actually count it since it is a horizontal line. So the same thing is going to go for EF. So on here, if you see, there's 4 boxes across. So we can say that EF equals 4. So how do they compare to each other? We can see that EF is half of AB, which is true for the midsegment. Next, for number 5, we need to find the slope now of DE. So we need to find the slope of DE. So with the coordinates D and E, we need to subtract the y values on top, and then subtract the x values on the bottom. This means that we get a positive 3 on top and a negative 3 on the bottom, so our slope is negative 1. We need to now do the same thing for AC, which we can find our points up above, so we'd have 2 minus negative 4, and then underneath would be negative 2 minus 4. When we simplify it, we also get negative 1 for the slope of AC. Since the two slopes are exactly the same, we can say that these two lines are parallel to each other. Here is the whole reason what we're doing is to write the equation of the midsegment. So to write the equation, remember we have to find the midpoints of each side that we are connecting them to. We need to find the slope of that line, and then we need to put the slope and one of the midpoints that on that end of our line into point slope form. So I'm going to do number 6 and number 7 with you, and then number 8 you're going to do on your own. So with DE, you can see is right here in green. So my DE, I need to find the slope since I already found the midpoints of those two. So to find the slope of DE, we need to do our rise over run, which if we count up and over, we can go up 3 and left 3, so our slope is negative 1. I'm going to use my point, let's see, 2, 2. And now we can put those 3 numbers into point slope form. So the first number would end up being a 2 for our y value. Next will be the slope of negative 1. And then the last number will be the 2 from the x value. So if we're going to use it, leave it in point slope form, this would be our answer. So go ahead and label what the slope is of side DF, so midsegment DF, and write down the point. All right, so the slope of df should be 3 over 1. So the part in the yellow right there will be rise over run, so 3 over 1. So I'm going to use the slope 3 over 1, and then my point I'm going to use is point D again, so 2, 2. So this is what your setup should have looked like. So we get y minus 2 equals 3 parentheses x minus 2 as our equation. And again, remember, if we want to put it into point slope form, this would be it. If we want slope intercept form, we'd have to distribute the 3 out in front and then solve for the y. So what I want you to do now is for number 8. So I want you to try this one on your own. So remember, you have to find the slope of that mid-segment, the orange line inside our triangle. Then use one of the endpoints and the slope to write your equation into point slope form. Alright, so your slope, since it is a horizontal line, should end up being 0. You could either chose the 5, negative 1 or 1, negative 1. So I'm going to choose point E. So when you put those in, the y value will be a negative 1. The slope will be a 0. And then the x value will end up being the 5. As you've seen it on some of your different equations, this equation was simplified slightly, so it's y plus 1 really on the left-hand side, and then since you have a 0 for the slope, that means the right-hand side will end up being just 0.